Okay, this seems a little weird, but we are going to call this unit Unit 4 as well. So we're going to have two Unit 4s. This is the second of the Unit 4s. It is about descriptive statistics, which is a fancy way of saying we are going to analyze some data and talk about what trends there are. Section 4.1, we are going to start by describing data. Some of it's going to be review, and then there's going to be some new stuff as well. First thing is just a bunch of definitions. So at some point here, pause the video and get all these definitions down. Data are facts and statistics collected to help you learn about something. So that's what this whole unit is about, all this data. Mean, median, mode, and range. You guys know these. You've done these in middle school. You're familiar with them. Mean is the average, of course. You add up all the numbers and you're dividing by however many you added up. Median, when you put a list of values in order, the value in the middle. You can technically put them in any order you want, whether you want to do least to greatest or greatest to least. I always prefer least to greatest just because that's counting order. That seems to make the most sense. If there are two values in the middle, we know we need to add those up and divide by 2. Essentially, you're averaging the two middle values. Mode is the value that occurs the most, and range is the difference, which of course means subtraction, between the highest and the lowest values. So again, you need to pause this if you have not already and make sure you write these down in your packet. Okay, our first example, consider the following set of data which describes the length of 6 naps that Mr. Bruss took over a 2-week period, and the numbers are given in minutes. So here is our data, and we want to find the mean, the mode, the median, and the range. Okay, so mean, you want to find essentially what we call the average. So you're going to add up all the numbers, 38, 40, 44, 45, 45 again, and 58. So I would just pull out my calculator and add up those numbers. Let me make this a little smaller. So 30, oops, let's get on my calculator screen. 38, 40, 44, 45, 45, and 58. Hit enter. So we get 270 for that. And then you're going to have to take that 270 and divide it by 1, 2, 3, 4, 5, 6. There are 6 numbers because you have 6 naps. So 270 divided by 6, my answer divided by 6 is 45. So our average for our mean is 45. 45 what? 45 minutes. Okay. Notice how I did that in my calculator. What would happen if I did it all in one step? 38 plus 40 plus 44 plus 45 plus 45 plus 58 divided by 6. Think I'll get the same answer or a different answer? Different. 665 over 3 is not 45. Why am I getting a different answer? Look what the calculator did. We want to add up all of the numbers, take that sum divided by 6. But if you type it all in at once, your calculator is going to do order of operations. It's going to do the division first, and it's only going to divide the very last number. So if you want to do it all in one step, you need to use parentheses. So parentheses, add them all up. And then outside of the parentheses, divide by 6. Okay? So 2 different ways you can do it. You can do your addition, hit enter, then divide. Or you can do it all at once, like this one, by using parentheses at the top. You also could, in our calculator, do that, get the fraction button, and in the numerator, do your addition. It's the exact same thing as what I have up there, just a different way to get it. So however you want to do it, just be very aware that you can't just hit plus, 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 divide by 6. It won't work. Okay? All right, so that was our mean. Next up is our mode. To do your mode, you're going to want to make sure you, just kidding, I was thinking median. So on your mode, it's just the number that occurs the most. So we have 38 once, 40 once, 44 once, 45 twice, and 58. So the number that's in our list the most is, of course, 45. Median, you want to put your numbers in order, whether it's least to greatest or greatest to least. In this case, they're already in order, so you just want to find your middle number. Sometimes students like to cross one off on each side, keep going until you get to the middle. Well, here we have two middle numbers. If there are two middle numbers, add them up and divide by 2. Essentially, you're finding the mean of them. So 44 plus 45, well, that's 89. 89 divided by 2 is 44.5. So your median, 44.5. Range, your highest value in this list is 58, minus your lowest value here is 38. 58 minus 38 is 20, so the range in that data is 20. Hopefully you guys remember all of this from middle school, and this should have all been a review. Okay? The following data here describes the length of 6 naps that Mr. Bean took over that same time period. Okay, so same type of thing. You guys go ahead and do this problem. Pause the video now. Okay, check your answers against mine. Mean 45, there is no mode because everything appears just once. The median is 36 and the range is 82. Okay, now why do we do all this stuff? Well, you're supposed to learn something from these numbers. So my question for you, justify this. Justify your answer. Who takes longer naps, Brust or Bean? Whose naps are more consistent? Justify each answer with a complete sentence. Think these over, compare all of your numbers for Brust and Bean, and see what you can come up with. Pause the video now and do that. Mr. Bean and Mr. Brust have similar mean nap times. In fact, they're the exact same. They both have a mean of 45 minutes for their naps. However, Mr. Brust's median time is much higher than Mr. Bean. So if you look at the median of Mr. Brust is 44 and a half minutes, but the median of Mr. Bean's is only 36. Okay, so his middle number in his minutes of naps is much smaller, or quite a bit smaller than Mr. Brust. Therefore, I would say Mr. Brust takes longer naps on average. So what that means is, at first you might have just said, oh, their naps are the same because the means are the same. But if you look at your median numbers, you will see that his naps are generally shorter. More of his naps are shorter than Mr. Brust. Mr. Brust's naps are, more of his naps are longer because of this median number being different, one being smaller than the other. In addition to that, Mr. Brust's naps are more consistent. Mr. Bean has a greater range. So he has a range of 82 minutes. His longest nap is 100 minutes. His shortest is only 18. Here we're on Mr. Brust, we're only going from 58 minutes to 38 minutes. So his are more consistent. He's pretty consistent in the length of time he takes a nap for. His range only being a difference of 20 minutes from his longest nap to his shortest. So this range being way bigger than this range is telling you his naps are more consistent. Okay? So the big issue with Mr. Bean's data is this one number right here. That number, we could call that an outlier. It doesn't fit in with the rest of the data. Okay? It's almost double the next largest value. Okay? So what we want to figure out is something called standard deviation. What's standard deviation, you ask? Good question. It's just a way to measure how spread out or how much data varies, also known as the variation. That's all it is, okay? So we're just trying to figure out with that data set how to figure out how spread out the data is. Are all the numbers roughly the same, or are they spread out a ton? Do they vary a lot or just a little? So with this data, we could see with Mr. Bean's, it varied quite a bit because of this high range, versus this one didn't vary as much because of the smaller range. but that's just one way to find it. These four things are just one way to look at your data. Standard deviation is a different way to do it, and usually a better way. It's going to give you more information on how spread out or how varied the data is. Here's how you find it. It's really ugly, but we're going to break it down. Right? Not so fun, okay? These are like little, we call these bars over top. It really should look like this, but I had trouble typing it. It shouldn't be like that whole space above it. But it's typed on your paper, I think. You can see it on there. Okay, so it's going to be kind of hard to plug this in. So what I'm going to do is break it down into steps. And I'm going to tell you the reason why we're doing each step, so hopefully it'll make sense to you. Step 1, you need to find the mean of the data set. Why are we doing that? Because the mean is going to give you, quote unquote, a middle of the data. Quotes because sometimes you hear middle, you think median, but we're talking about a mean being like the middle. Because your mean, if you think about it, your average is kind of also a different way to talk about the middle of the data. It's where it would average to. Okay, then you're going to subtract the mean from each value. And we're going to do that to find how far away from the middle each value is. Square the differences that we just found, and that's because we want to make the values positive. Whenever we square a number, even if it's negative, it's still going to turn into a positive. Okay, so that goes with that. Then you're going to add those numbers up and then divide, and both of those things are done to find the average. Adding up, dividing by them. That's how you find the average, and that's the difference because we were talking about differences here. And then finally, you'll take the square root, and you've got to do that because of up here when we squared it. So that'll undo that squaring. Okay, lots of stuff happening here. Hopefully you followed some of that, and if you didn't, maybe it'll be more clear when we do an example. So we want to find the standard deviation of the length of brush snaps in minutes. Okay, so first of all, I needed to put those numbers in. But now that those numbers are in, we're going to follow these steps. Step 1, we want to find the mean of the data set. Well, that's the same data we just dealt with. Okay, so we've already done that. The mean that we found on the data was 45. Okay, so the average, the mean, we already know it's 45. There's step 1. That gives us our middle, quote unquote, middle of the data set. Step 2, subtract the mean from each value. That gives you the deviation from the mean, how far away from the middle each value is. So be careful the order you're doing it. Subtract the mean from each value. So 38 minus 45. Careful of that order. -7. 40 minus 45 is -5. 44 minus the mean, -1. 45 minus 45, 0. 45 minus 45 again, 0. And then 58 minus 45 is 13. Okay, so that's step 2. Now we know how far each data value is from the mean. Step 3, square those differences, and we're doing that so we're working with all positives. So your squared deviation from the mean, -7 squared, by the way, total side note here, sometimes students will say -7 squared, oh, I'll put that in my calculator. My calculator said it's -49. Mrs. Fishel is telling you that's wrong. Your calculator's not broken, you're typing it in wrong. If you're typing it in like this, you're telling your calculator just to square the 7, not the negative. So your calculator brings the negative sign down, squares 7, and gets 49. That's not what we want to do. We want to square the -7, all of it. So you have to do it in parentheses because anytime you square a number, positive or negative, it should become positive. Now, if there's an extra sign somewhere, like out front, that will change your answer. But we are simply squaring this number. That makes it positive. -5 squared is 25. -1 squared, 1, 0, 0. And 13 squared is 169. Okay, that was step 3. Now we have all positives that we are working with. Step 4, add those squares that we just found. So this bottom row of numbers, we're going to add all of those up. Okay, so let's see. don't have a good way to be able to see everything. Yeah, let me just try. Okay, so 49, 25, 1, 0, 0, and 169. So I don't need to add the zeros, obviously. Okay, so that gives me 244. And then step 5, divide the sum by n minus 1. Okay, so I'm doing 244. Well, what's n minus 1? N is how many numbers we have. N minus 1 is one less than that. So we have 6 numbers. So we don't want to divide by 6, we want to divide by 5. And you might be a little confused on that because normally we divide up by how many we're adding. But when you're doing standard deviation, it's actually better to divide by n minus 1. It's out of kind of the scope of this course to explain why that is. So maybe when you get into some higher math classes, you'll get an explanation. But for right now, you just got to trust me on that. You're dividing by 1 less than what is there. So 244 divided by 5. You guys know this ANS, it just takes your last answer and does the problem with that. So our last answer, 244 divided by 5, gives you 244 over 5. Our calculator defaults to a fraction, but in this case, when we're working with standard deviation, we do want decimals. So you can, 2 ways to do that. Well, let me show you the one first. So if you have the fraction in there, menu, number, and we want to convert it to a decimal. Hit enter. The other way to do it, you can type in 244 divided by 5, and then you hit control enter, and it'll give you the same thing. Okay? So we get, when we divide that, we get 40, I already forgot what it was, 48.8. Okay? That essentially is finding the average difference. Finally, the last thing you have to do is take the square root. So we are taking the square root of 48.8. Or you can just hit Control X squared to get your square root, and then Control the minus sign will stick that answer in, or of course you could type in 48.8, and we get 6.9857. 6.9857. That's already rounded, but we want to round it a little further. We want to go to the nearest tenth, so we would look here to round. This 8 makes the 9 go up, which makes the 6 go up, so our standard deviation is approximately 7.0. So the bigger your standard deviation is, the more spread out your data is. The smaller the standard deviation, the closer together your data will be, which means your numbers are going to be like a small standard deviation, your numbers are going to be very close to one another. A higher standard deviation, you're going to have numbers that are further spread out. Okay? All right. I want you guys to pause the video, and I want you to go through all of the steps. I know there's a lot, so that's why we need to practice it. Go through all of the steps to find the standard deviation of the length of beans naps in minutes. And you've already got those, and you already have step 1. Remember your steps. You already have step 1. We already found the mean of these numbers. So step 1 is done. Continue on from there. Pause the video and work the problem out. Before you work this problem out, or before I show you my worked out, because you probably already paused it, I'm wondering if you expected to have a higher standard deviation or a lower standard deviation. Think about that. Okay, I expected this to have a higher standard deviation than the last set of information because I knew they were more spread out. I knew I was going with numbers that were further apart based on my range and based on this outlier here. And sure enough, the standard deviation is a bigger number. It is 30. So what does the standard deviation tell us about the difference between Mr. Bruss and Mr. Bean's naps? It is telling us Mr. Bean's naps have a higher standard deviation. Therefore, there is more variability in Mr. Bean's naps, meaning Mr. Bean's numbers, those number of minutes in his naps, can vary more so than Mr. Brust did. So that's what standard deviation is telling you. It is telling you the variability. How much does your data vary? Are they all about the same number, or are they more spread out? Okay, the last thing I want to do, which we haven't done yet, which is actually on the first page of your paper. It's actually not the last thing. There's one more thing to do. But I want to show you how to do these in the calculator. You certainly don't have to. It's not required, but it can definitely be helpful. So if we are on our calculator, on your calculator screen, menu, statistics, list math, and then this is where you can do mean and median. So if you want to do the mean of some numbers, maybe 1, 2, and 3, you would just hit 1, type a comma, which is right here, 2, comma, and 3. Hit enter. Okay, hold on, I don't know why I did that. Yes, I do. I skipped a step. We have to first save our list. Okay, so rewind, don't do that yet. You need to type in your list of numbers first. When you do that, you want to use curly brackets, which are control and then the right parenthesis. Control right parenthesis gives you these curly brackets. And then we want to use set notation, which you guys have seen now for a couple units, to list your data. So 1, comma, 2, comma, 3. So we have to list our numbers first in the curly brackets, and then you can just hit enter. But we want to do more than that. We want to store this data. So once we have those, don't hit enter. So once we have those typed in, then you're going to control VAR, which is going to store, and you can name this whatever you want. I'm just going to name it list A. Now hit enter, and if you just type in an A now and hit enter, it's going to say, hey, I know what A means. A means the list 1, 2, and 3. Okay, so are we clear on that? So curly brackets, control, right parenthesis. Hopefully you're writing these steps down. Pause the video as needed. Type your numbers in separated by a comma, and then control var to store, and then you can pick what variable you want to store it as. Okay. You can check to make sure it's stored correctly by typing in the variable and hitting enter, making sure your data is there. Okay, then you can go back to that menu, statistics, list math, and what operation you want. We want to take the average of those numbers. So we're not going to type our numbers in there. That's a mistake I made before. We're going to type the variable in that we named our list. So the mean of A being this list of numbers, is 2, which should make sense because 3 plus 2 is 5 plus 1 is 6. 6 divided by our 3 numbers is, sure enough, it's 2. You can also do the menu, statistics, oops, not that, list math, median of A, hit enter, and it is 2 because 2 is your middle number. It doesn't do the mode or the range, but what it will do is if you have a list that's not in order, you can order it on your calculator, and that is under menu, statistics, list operations, and you can either sort it ascending or descending. Well, our list is already in ascending order, 1, 2, 3, so let me show you that you can do it to descending. And you just want to tell it what you want to sort. We want to sort list A. Now it already did it, so now if I type in A again, now it's going to give me that list back out in the other order. Okay? If you wanted in ascending order, which would be normal counting, which we would normally do, menu, statistics, list operations, sort ascending, tell it to sort list A, hit enter, it tells you it did it, and then to see it, there you go. So it'll sort that, so then you could easily do the range, biggest minus the smallest, and the mode to figure out what's in there more than once. Okay? So your calculator does all of that for you. Do you have to do it in there? No. Is it nice to know in there, especially if you've got a ton of numbers? Yes. Big thing is you have to make sure you type everything in correctly. You are responsible for knowing these steps. if you want to use your calculator to do it. You need to know how to do it in the calculator, and you need to make sure you type everything in correctly. Lastly, your calculator will also do your standard deviation. I want to show you with this last example. Okay, I do expect you to be able to show work on these, but it is perfectly good to check your answer in here also. It's very nice to have this because there's obviously a lot of steps, which means there's a lot of places you can make mistakes. So first I'm going to type in this actual data. So control, right parenthesis, and then I'm typing in my numbers, separating them with that comma button. Oops. Okay, see how easy that is to type something wrong? Make sure you check your numbers. I want to store this. I'm going to store it as A, which means it's just going to overwrite what I already had in there as A. You could pick a different letter if you want to. Oops, I don't want to put that in there. I need to put it out here. Okay, so there is my list A. Now I want to know the standard deviation of it. So menu, statistics, list math, sample standard deviation. Let's see what happens. You want to do that of your list A. And we get 29.96, which would round to 30, which is what we got. And 29.96 is what we had over here as well. Okay? Okay, so again, it's not required that you use your calculator, but it's certainly nice to be able to do that in there and check your work by hand that you had done by hand. All right, one more type of problem. Find the value of x. So they gave us a list of data, but we're missing one of the values. But they have told us what the mean is of those numbers, including the missing one. So you're just going to set this up. Normally to find a mean, you would just add up all your numbers, right? 13 plus 9 plus whatever that is, plus 9, 4, and 17. And then we know we would have to divide all of that by how many there are. Well, there's 6 values. And then we would find the mean. But we don't have to find the mean. They gave us the mean. So we know that this whole thing is equal to 12. So at that point, you just have an equation that you need to solve. So I'm going to use my calculator that I have in my hand here. 13 plus 9 plus 9 plus 4 plus 17. That gives me 52 plus the x that we don't know over 6 equals 12. And then to solve this, we would have to multiply by 6, which gives me 52 plus x equals 72. Subtract 52, and x equals 20. So the missing data value is 20. If I had a 20 here, then the mean would actually be 12. So you could check that. 13 plus 9 plus 20 plus 9 plus 4 plus 17. Divide by 6. The mean is in fact 12. You can do that with any of these operations, whether it's mean, median, mode, range. One of them's missing. You're going to do the same thing. So if we know we have these 4 data pieces, but we don't know this one, but we know the median is 27. Keep in mind how you find median. You put them in order. But we don't know where the x is. Okay, but we know the median is 27. So if you think about that, x can't go here, because if x were here in this order, your median would be in between 20 and 25. 27 is not in between 20 and 25. If we put the x in the next available spot, which would be between the 20 and the 25, then your median would be in between these two numbers. It'd be between 25 and something that's smaller than 25. Well, 27 does not fit that criteria. So if we put it in the next spot here, your median is in between, because 2 on each side. It'd be between 25 and something that's bigger than it, but definitely smaller than 90. That makes sense. Okay? If you're not sure and you check the last spot, if this x weren't here for a second, your median would have to be between 25 and 90, which it is, 27 is, but of course if you average 25 and 90, you're certainly not going to get 27. So that means it has to go in this spot right here. So our information looks like this. So that's how you figure out what spot it goes in. And then To find the median, we know that we need to take those two middle numbers, since it's an even amount of numbers, and then divide it by 2. We're going to get 27 when we do that, so it's just a matter of solving. Multiply by 2 on both sides. 25 plus x equals 54. And then you would subtract 25. And then 54 minus 25 is 29. So our missing piece of data must have been a 29. Okay, finish your packets.